Hello everyone, this is an ETABS tutorial. In this tutorial, we're going to model analyze our multi-story shear wall structure. So ETABS V22 is the latest version of the ETABS, which is available in the market. If you have, it's okay. If you don't have, you can download from my Telegram channel and follow this tutorial, and you will completely know how to use this software. So in this software, we will consider some new tips and tricks, and additionally, we will consider to model design beams, columns, slabs, and shear walls. So in the later, we will discuss the SAFE 22 V2.2, which is the latest version of SAFE. Then we will design the foundation of this structure. So it's a step-by-step tutorial, and we will follow all the steps and to model design a multi-story reinforcement concrete structure. So the first thing is when you open, you will come to the new model and change the unit that you want to use. So basically, I use metric ACI standard, and for the material, you can use any material library you want. So I think for me, I use a United States material, and in case if you have a composite structure that you want to design with concrete, such as the selecting the steel section database, you can use AISC 15 and metric. And additionally, for the design of the steel concrete, you can use the latest AISC 36022, which is the latest update. So for the concrete, so as you know, we use the ACI, American Concrete Institute. The latest version is 19 in this program. So that's way okay with the units and material database. So now we choose the grids, and we also have some additional predefined structures. You can choose it. So I use grid only. Then I will define my elements one by one. So in my planned structure is 3 by 3 base. In addition, we have a short base in the middle of the center of the structure, which is for the elevators. So in this case, I have 5 grids in a X direction. If I want to model this one, I can come to the drawing and take the pen with any color you want. So this is it. So this is the X grid. So I'm gonna give the number of grid in X. So this is 1. The second is 8 meters. The next one is about 3 meters, and the second is also 3 meters. So this is basically 1, and the last one is also 8 meters. So this is 1 bay, 2 bay. So we need 1 grid, 2, 3, 4, 5 grid. So and Y, I need only 3 grids. So 1 is 6 meters, and it's another small one about 2 meters, and this is also 6 meters. So 1, 2, 3, 4. So this is a grid that I want to explain. So the 4 is okay. So the number of X sizes. So basically we have 1, 8, 2, 8. So suppose it's a office building, which is one office is here, one is this one is here, 4 office, and these areas can be used for the other purpose, for the like some kitchen or some things, and this area will be for the sitting halls, and also this area centers for the elevators. So where we have 2 elevators, which we use solid shear walls, and the rest will be beam columns. Now what we're gonna do is we're gonna add 8 meters, then 3 meters, 3 meters, and 8 meters. And the other side is also be 2 meters, 6 meters, 2 meters, 6 meters. So we can actually do it here, then later we can change it. So we also use this one, this spacing, and we can go to here, customize it way, and you can see basically here. This is the X, so we need to change it. Let me use this one. It's called split grid spacing. So the first one is 8 meters. The second one is, as we discussed here, is 3 meters. You're gonna write 3, and the second is also 3, and the last one is also 8 meters. So you can understand. Here in the Y is this one, which is 6 meters, 2 meters, and 6 meters. So we have done. We call okay. And the important thing is that the number of floor. So it's a 12 floor structure. So the top floor above second floor, above the ground floor is 3.2, and the First floor is 3.6 meters, or you can consider 4 meters. So then I said, okay. Now, the second thing is that we must define materials that we want to build our structure. So we go to define. We're going to define, we use high strength concrete. So basically we use concrete 6,000 psi. I add a new material. I selected concrete, and here is the 6,000 psi. So this is the default strength and modulus of velocity, Poisson ratio, and other specification of the material properties. You can modify this one, and particularly the grades and the strength. So we consider that 41 is okay. If you have a tested material, and then you can change it here. Additionally, you can actually calculate the modulus of velocity when you have this one, the strain, the compressive strain. So then you can calculate the modulus velocity. With they're giving compressive strain, we will calculate modulus velocity this one. So okay, and we have this one. Additionally, we use steel grade 16 for the this one. So when I say okay, we have two materials, so some other default material is available. So okay, and we go to the defined section. So the first section is the column section. We assume the column is uniform from the first floor to the top floor, because for the simplicity of the tutorial. But in case you must use different or varying column size to consider the stress, the stiffness is distributed structure differently. So I come to here and I want to define a concrete rectangular column, and then I say column. You can actually model different columns, such as L section column, T section column, any section that you want. But this the simple model is called box, or let's say box or square sections. I'm going to be 80 by 80, which is 80 by 80 centimeters. So I'm going to call it 80, and this will be 80. So additionally, I must choose the concrete materials here. Use 6,000 psi, and the reinforcement. So the reinforcement grade is 60. So it's a column, and it's a rectangular shape. And I want that clear cover is 40 is okay. So because it's automatic, the program will automatically determine based on the given load. So I let the program choose the higher rebar to 22 for me. And suppose I want to use the number of longitudinal bar along the third. You can see a third 2 by 3 and 5, and you can see totally like 5 is here, 5 is here, 12 total. And additionally, you can the confinement which this strap is 10. So I can keep them here in case if doesn't satisfy, so we can increase the rebar. So okay, and now it is done. Additionally, we have some more things called property modifier. You can change this one in case if you want to consider the crack in this element. So I assume the crack is not allowed in this elements. Okay, now I'm gonna take a copy of this one, and I'm gonna do it called beam. So the same material, but the beam is going to be half of this one. So going to be 400. So the depth is 400, and I'm gonna come to here, change the beam, and the cover the cover of clear cover is about 60 or 6 meters. So we can change this one to be about 40. Then in the code, it's recommended that should be over 50 millimeters. So this is it. Okay, we can select these two things. Now we only have two. We consider that the structure as uniform, but it's not practical. You can actually like 3 floor or 4 floors, one type of section, and the top is a little bit lower because the stiffness should be distributed in the top. The length is going to be higher, so the displacement will be more. So you must be using slight lower stiffener element, so you can like 80 centimeters is lower, so it'll be 60 is in a 3 section. So additionally, we will define two other section, which is called solid section. We can come to the define section, and here is called one is slab, one the second is wall. So slab is a uniform slab for all of the structures. So we just change the material, and we consider shell 10 elements, and we changing the thickness. The thickness is 200 is quite enough for this structure. So okay. And additionally, we come to the wall section, and we want to, in the wall, it's okay. You should use a uniform because it is the left. So the left will be it need a quite uniform stiffness from bottom to top. So you need to give the shear wall uh, or the elevation wall is uniform. So we modify this one. We change in the concrete, and we also give the thickness. So the thickness is 300 is okay. It's quite enough. And they also have some modifier in case if you consider the crack. So it doesn't want to study the crack impacts this structure. So we not modify. Okay. Now we have defined the material sections, and now we start modeling. In the modeling, we have some options such as here, one story, all story, similar story. So this is all, actually this is called all story. If I model one, so it can go to the all, is okay. Okay, I'm gonna go one, and this we model all is okay. Because basically I have just one story. Additionally, we also can use one and then duplicate them to all. So let's use one and then duplicate. So the first thing is I wanna define my shear wall first. Come to here. Just click here because it is click here, and then you must use a draw wall. And in the draw wall, you can actually call it pair, and it's the wall that we want. So the wall is like this. Also this is the wall that I'm going to draw it. Basically, this area is open, so this area is open, and then we don't need it. So this is the shear wall. Oh, it's actually I'm in floor 12, so I must use this one. Come back. Yeah, I'm going to go here, and it's be first floor. Now I'm gonna try it. So this is it, and we are done in the first part of the shear wall. The second is the drawing of the columns. So you can draw beam columns using this one, or you can use automatic column. So the column is here. You must select that column that we defined. I'm gonna make something a little bit different. So I'm not going to use column here, and instead using this in this area. So the rest, I'm going to use this one also a shear wall in these two direction. So that's something be much more strong. So I'm going to back to here, and I have the same shear wall, and I'm going to select here one shear wall and one shear wall. And now I'm going to use beam. Additionally, we have one we called lintel beam, and we need one little bit a lintel the sort of beam here. We call lintel beam. So I must select here, and or I must select using this one as well. So it's going to be frame edge beam, and I'm going to select this one, this one, this one, and this one. This part is no need. Yeah, this sorry, I must okay, here, yeah, yes, and this one and this two part here, and these two parts should be one single. We use these techniques. So using this one and using beam again, 6 meters. Oh, that was use this one. Remember to do the center, otherwise you will disconnect it. So now it's okay. We need a lintel beam here, so I can use the same things, no problem. Meters, 3 meters, 3 meters. So no, it's okay. If I go to this beam is still okay. Now I can go to the first floor, and I can use some extrusion, and you can see the structure is like this, so quite stiff. And now I'm going to model the floors. So I'm going to using this floor. So I'm going to take this point, this point, this point, this point, and yeah. So this is done, and I'm going to do an opening. So I can call it as here opening, and so in the opening you can actually use here, and also use instead of open here use opening. So I'm going to take this point, take this point, take this point in. Yeah, now you can see it's opening. So here is the opening. Now we will apply the live loads and dead load to the floor. Because it's a uniform slab, so you also can do it in each of the this area. So I selected the slab, and in order to see here, we can go to the this command. We want to see the opening area. Object assignments, here we can see opening shell elements, and we have to find the opening. Okay, no problem. Okay, now I'm going to model the slab. We come to here, and the first thing is that select this one, and select slab, and then select points here. So the slab is uniform, and then we will cut the opening in the shear walls or elevator areas. So that's it. Just change a little bit. Again, center to center. Okay, now it's done. And the next is we're using the same technique. Instead of slab, we want to use opening, and from this point, from this grid point B, and this grid, and this grid here, and here. So we use open. So this area is open. So now we will apply the load, the live load and dead load. So if you want to add some extra loading patterns, you come to the define. You come to the define. Here is called load patterns. So basically we have two live load, dead load. So additionally we will use a super dead load, and super dead load is here. And I'm going to add, additionally we have earthquake load, EX, and yeah, we can call it seismic load, EX, and seismic. And the code is using ASC 722, which is the latest version of the American design code. So in the Y, in the direction, some could also consider the earthquake in vertical as well, so like the Chinese code, but if you consider to design in dynamic steps, so if you want to use in dynamic, so then you have to consider the vertical as well. So here is also possible. So in my point, so I just make it simplified, just 2 XY is okay for me, and I must modify this one, exactly defining that, particularly that x is x direction with some eccentricity about 5%, and let the program determine the time period of the structure using this equation. You can go to the chapter 1 2, which is the C factor is giving. If the C factor is giving this 1, so the program will calculate your time period. This is depending to the seismic zone, so we're using this one, and we have two methods. So the first method is you using a uniform response spectrum, which is early should define in a response spectrum, or in a second method is that you just give the short period acceleration and the long 1 second acceleration. So in a short period is 1.8 in my study. So which means if you find the location such as in California, it's about one. Each region has different response spectrum. So you must use there is some tool in the website of AC7. You can actually point exactly that location and it will give you this parameter. So it's basically an approximate. So and in always remember, so the 1 second, which is if you draw the response spectrum curve, if we draw it, so we have actually this one. So the short period is this point, and then which is the tallest one, short one. Then it will be basically like this, and then yeah, this one, and then it will come like this. So this is the 1 second. So this is the short period and the one. So I must give it 136, and here is one more things. The design spectral acceleration for site class BC. You must include this in the previous one. It doesn't work, so automatically the program will calculate design S, DS, and also some other parameters. So I'm giving this one is almost 86. So the long period transmission is, yeah, we consider in this one, which is 8 seconds. And the site class is actually site class BC. We're giving BC. If it's different, then you must verify it. So this is the response modification R, and in this kind of steel is about to be 6, and occupancy is 1, omega is 2.5, and the deflection amplifier is 4. So, and that's done. Okay, and the same things I must go to delete this one, and I'm going to add a copy of this one. Okay, and then okay, must call it Y. Okay, Y, and then same thing. So I'm going to modify this one as well. So this is Y, Y, and the same method we're using 5%, and here is so we also modify this one for Y just using meter 2. So 1.8, 1.36, this is 1.776, and this is the long period is okay. We use BC, and this is the modifying factor. This is 1, and this is 2.5, and this is 4. So we're done here, and you can go to this code and you can choose if your structure is it has a very we call this not a special shear wall or special moment. It's ordinary. So for this one we have this data. If you have some special moment resisting frames or special shear walls or some other thing, then you can go to this code. You can choose it exactly. So okay, and now we go to the select this section. I'm going to assign, and it's called shell loads. Shell loads. So in the shell loads, we have uniform loads. So the first one is date load. So we don't have this is the date load that we want. So it's a gravity form, and it's about to be 5.2 kilonewton per square meters, and you can see, 5.5 apply, and the load is applied. Now we select again, or using this command is called previous selection, and then we come to the live load. So live load is about 4.8 in the office. So okay, we select it, and we don't have anything else. we can actually come to here, verify that the load is added or not. So come to the load and we have 4.5. Now the first floor is completed. One more thing is we also can add, we can select this one and we want to assign here. We called the first thing is we called shell and diaphragms. So we using diaphragms. There's one which is a stiff one, and the second is okay, and we select it here. We want to add some meshes as well. So shell elements, going to uh, uh, here it's called floor mesh, floor auto mesh. You can use it floor auto mesh, and you can mesh object should be for 4 by 5. I'm going to use 20 by 20 because it's all a single element, so be much more. So we add in 20 by 20 meshes. Now we can also go to the select here, select. Go to the select using properties is also okay in wall section, and we have this wall select, and we want to assign meshes also here. We can assign meshes using shell, and it's called wall auto mesh, or we can actually divide it separately. So we're using this 5 and 10 by 10. Okay, and we also mesh them. We finished. Now we're gonna go to the select. We're gonna select all, and then okay, we're gonna select actually the entire structure. I can select like this one. So I selected all of them, and I'm going to edit, and it's called replicate. So in the replicate, it's gonna be story, and I'm going to replicate them to all above the stories, so you can see it. Okay, now the structure is here, completed the modeling, and only thing is that we wanna go to the bottom flow, and we will add a fixed support. Sign, join, string, and I'm gonna fix support. So now the structure is completed. And next, we can go to the define combination, define, and we do a load combination. In the load combination, we have automatic load combination or also manual. You can consider, but automatic is okay. At default, and we're using is concrete frame, concrete shear walls, concrete slabs. So if you check this one, so later you can actually edit this one, this combination. So you can see here, modify. Yeah. So remember this y is using minus, so this is a program will actually determine. So you have two dimension, and it's using minus and positive. So now we are completed, and we can go to the analysis, check the analysis. But before the check analysis, we come to the here set degree of freedom. It's a 3D model, and you call the analysis, check the model, and we're going to select all these things for check. So then as we check is running. Yeah, there is no problem, and we can actually save our model. We should preview save. So we saved, and we want to run the analysis. So when you run, so remember one thing. This is a linear analysis, linear design. So we didn't define the structure as a nonlinear. So now the analysis is running, because we have several combination. So that combination causes to take some time. Now the analysis completed. Yeah, you can see the deformation shape of the structure here. But we want to here, let's go to the go to up stories. I can go to the elevation. Let's go to the elevation A is okay. This is it, and I'm going to see the deform. Yes, using combo. But before this, let me go to the model. We should modify the model analysis, but we only have 10 mode here. So this is the first mode, which is 1.1 second almost. So it's okay, because if we have a equation, if you want to take the time period of the structure, so it's about 0.1 multiplying by the number of story. So h, so number of stories is 12, and it will be 1.2. So basically the structure is much more stiff, so it will be 1.01 second. So it's okay, it's acceptable for me. This is the first mode. If I go to the 3D let me turn on this one. It's going to be 3D. So this is it. If I want to see this direction, if I go to the second mode is that direction, basically a little torsion as well. So this is the torsion, and this is the mode shape of the structure. We also can delete them too. Okay, after you can evaluate the number of mode and the deformation of the model analysis, then the second is you can come to the display here. In the display, you can see the structure story response by coming the story response plot, and to the XY, and you can see the maximum displacement of the stories. So the top story is about less than 100 millimeter. And we can understand this one, how much is the allowable displacement, and then how. So basically you can come to the story drift. So this is the good idea, and this is the draft. In reinforcement concrete structure, about 1 to 2% is allowable draft. So if you want to build a structure, so if 2% has a moment drift like this, so it's okay, it's in the range of safe. But if it's greater, then you must increase the stiffness of the structure or use some other sort of seismic anti-seismic earthquakes device to reduce that drift. So the drift is less than, if you multiply by 100, so it's be less than 2.5%. So it's 0.27, which is less than 1. So the structure is quite stiff, and it's okay. You also can see that in the y direction. So in the y direction, in maximum story drift, all story. So y1, yeah, that's y1. So it's a little bit higher than the previous, the x, because the stiffness is less in the y direction. So what we're going to do is next we can also consider the shear, the story shear or story shear force, and you can see the bottom is quite high, about 8,000 kilonewtons. So then the top of the story is less. So this is okay. We have completed the analysis. So the next thing is we should design. So the design of the structure, you can actually take this data, especially the drift and displacement, and then check with the allowable drift ratios. So in my opinion, if I reach with this modeling with less than 1%, so it's okay for me. But the structure is quite stiff, so we can keep it in the range of 1 to 2%, so that will be okay. Now for the designing of the elements, we can start design the beam column firstly. You come to here, you check the preference code, and you can explain to the program what type of structure is this and what is the parameter that you want. The seismic category is here. You can see here is seismic category. So that basically that my structure is located in the seismic category D. So you can go to the ASC 722 and check that seismic category 2 is what kind of structure. So the rest is I keep it as it is, okay, and then going to do one more things about the some design combination groups. So I select all of them because I don't created groups such as the first floor column beams or foundations or slabs. Well, I didn't make groups, so I can consider all of them. So I'm going to run the analysis, the design. So the first step, the beams columns is going to be designed. So if I go to the one of the elevation, and let's elevation 1, and you can see the beam column is passed. So there is nothing they should say that there is, but the design is very good. So you can see first floor is going taking high reinforcement, and the top is less, so it's okay. So this is that's what we want. And additionally, we also can verify this one. We call verify the design, and section is all everything is passed, and also verify all member is passed. Here is something that is called 150 concrete fail to design check. So I'm gonna yes, because some of them we selected is a beam in some combination, which is in slab. So remember, and this is called slab design. So it doesn't pass. So we don't consider that the slab is passed, should be passed, because that's for the slab design. But mostly we have the first two five is for the concrete, which is passed. And you come to here and you say the detail, and the reason is here, which is giving shear is due to the shear force and torsion together exceed maximum allowed. So that is the in just in except for few combination or few load combination. In that case, it didn't pass. So the other is quite okay. Here is also didn't pass. So if you want to lead to pass, so you can go to the, it's all beams. You can come to the of it and just come to the section, and because that's the torsional, so the column, the beam section is a little bit tiny in this area, so we can add it 500. So in this 500, so obviously will pass. So I'm not going to design run analysis. So the analysis almost completed. So we go to the design again. We check the design. So obviously the top floor is passed, but just this floor is doesn't. So because of the stiffness distribution, so we must if you remember that this, if you go to display, come to the drift, you can come to here or then select X or Y. Yeah. So this from so we have only one diaphragm here, so we must give the diaphragm to all structure, then we can come to here. So we come here, and here is in this story between story 2, 3, 5, there is a quite large drift. So in this case, here the structure is didn't pass, especially the beams, because that large drift caused to generate some torsion here, but the risk is passed. So if we go back to the verified is one, so from 151.85 is passed. So in the next, we can even we can ignore this one, it's okay. We can consider this is okay, because there is two ways to solve it. One is increase the at least this area become 600 by 800, or the upper become 4 to 700. So bring some changes. Now the list is completed, and we go to the design the slab. In order to design the slab, we must come back to the one of the plan. Let's be follow one, and come to here, and I must add some we called straps. When you want to design, you must add some straps to the select the slab. We called here edit, and here is the slab the slab yeah add edit design steps. So based on the steps, so we're gonna using here is called story 1, and I must use the XY direction is be well, let's be O2 in a X direction. So you can, yeah, you must select it, apply. Yeah, we can see. No, actually we also need to add, because it's just only one taking large slab, but we don't want this one. So yeah, we use this technique. So the metal is also, so now we're going to come to the Y as well. So I'm adding this one, so you can see now we have different steps. Okay, additionally we can do one more things. We can select them all. If I go to select, I'm going to select object is okay, and I'm going to call the steps AB, which is select. Yeah, select them, and we're gonna call duplicate or replicate. So replicate to all stories. So we're gonna go to here and apply. Okay, so if I go to the second floor, so you can see all the steps is there. Additionally, we can select the shear walls. We can select shear walls. Um, so that would be okay later. So I'm going to run the analysis again. The analysis completed. So after the analysis completed, you come to the here, and there is a shear wall. Here is the shear wall design, and here is the slab design. So I must check again the parameters. So I'm going to keep it this one as it is, okay. And then asking to design. So I'm going to consider design all stories. So okay, and the program start to design the slabs. So the slab is designed, and you can see that the rebars here. If I go to one of the elevation, let's suppose to go to elevation, and you can see the slab areas as well. So top, bottom, and you can see how the moments and shear is distributed, and then in the corresponding area with the rebars. So we come to here. We again revise the. It's called wall type is special. No, it's not special. Just is intermediate or ordinary shear wall. And then again, the seismic design is taking the material is also. So we come to here. We call design. So the shear wall is going to be designed. You must select the design is automatically completed. And yeah, the design of Rebar so after the analysis design is completed, then you can actually come to here, verify it, and then that's all. So if we say that here is, we also can see the stress strain here and go to the display stress strain during the X, Y, or any combination. So you can see the stress strain in the shear walls. So now the design is completed for all the elements. So we can go to the detailing. So in the detailing, we can actually define some rules for the rebar, but we let the program do it like this. So the first thing is we want to do the beam detailing. So the beam detailing is completed. We can select all. Okay, it's gonna be okay, all or just first floor, and then you can see the first floor design is completed. Yeah, you can see here. Here is the beam. Some of them is doesn't because that area was still unknown. If you want to complete that one, so we should go back. Yes, we go back and we do that issues. So the most thing is I come back to here and I must define section. Come to the section, and in the beam, I should modify that beam to 600. So to avoid to, and that's be run analysis again. Okay, we can see the detailing of the beams. So when you see here, you can actually select any of the story that you want to see the details of the rebar. So I select story 11, I think 12, and here is the rebar, and between third and fourth, and here is the section, and here is the number of rebars that requires. So additionally, you can come to the 3D of that rebar, and you can see. So that empty area is okay. The empty area is something that didn't connect it because that area is column. So in this case, you can draw the beam from this point to that point. So that would be okay. like we did here. So in this area, we have totally uniform beams columns, and here is we know that it is the shear wall area. So additionally, you can actually see edge floors and also the location of the uh, beams that you want. So next going to the detailing of the in case if you want to do the foundation slabs also. So we have slabs, so we can go to the slab. Yeah, you must select one slab. So I'm going to select first floor slab. So this is the slab area, and I'm going to quickly to the 3D view of the slab. So this is the slab rebar, and I can go to the some sections like section A, section B, and you can see the details. Yes, and also the plain bottom top rebars that you want. And here is one slab. So the next, we can actually use some rows using a specific rebar or bar size, and additionally some something else. You can come to here. There is 4 things that you can change, but we just skip as a short. So the column is also going to be the last. So this is the column, and from the first floor to you can see floor 5, and here is the section. And if I go to the 3D view of the column, then you can see this is the column. If I go to the 3D view of the entire column of the structure, you can see we have these columns, and we have, okay. And now the last one is the shear wall. You can check the same things, shear wall as well. So that's all for this tutorial. In the next tutorial, we will actually do some other type of analysis and also nonlinear analysis as well. So if you like it, you can like and subscribe, and additionally you can recommend some other tutorials as well. See you next time.